Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight, Calculus 1 differentiation of a really cool problem right here, okay? Let's get after it. All right, we have, well, you have to imagine that's a straight line. It didn't come out very good. As I get older, I guess I'm a little wiggly. Okay, so we have this triangle, and the hypotenuse is going through point 1, 2. So x is 1, y is 2. You can alter that, pivot if you will, around that point. You can make the hypotenuse longer, shorter, however you want to, but you need to make that movement such that the area, the total area under the triangle is at a minimum. It's a pretty good little problem. So what do we do? All right, my plan in doing this was, in just thinking about it, I have this triangle, this rectangle, and this triangle. And I was thinking that, well, if I can define the area in each one, which, hey, I'll get the rectangle and then you get the triangle. Okay, the area of the rectangle is 2 times 1. Okay, but what about the triangles? All right, well, I have coordinates here, x, 0. I have a coordinate here, 0, y. Let me see, well, if this is x and this is 1, this length right here would be x minus 1. Okay, now then, I could define the length of that line by x minus 1. I can take the x values, x minus 1 squared plus 0 minus 2 squared, and the square root of that would be the length of that line. Well, 0 minus 2 squared is 4, positive 4. So I'm just going to write that as 4. Okay. Well, now what? All right, I have, since I have a line here, this line is parallel to it, intersects that line. I know this angle and that angle are the same. So I can use the concept of similar triangles to define the geometry of this side. So let me do this. I'll call this L2. Can you see that? Yeah. Okay, and I'll call, from this point out, I'll call that little L1. Noting that L1 plus L2 gives me the big L, the total length of the hypotenuse. But if I'm thinking about similar triangles, I could say L2 is to x minus 1 as L1 is to this side, which is 1. Hey, let me do that. All right, so I can say L2 is to x minus 1 as L1 is to 1. Oh, so that just means L2 over x minus 1 equals L1. L1 over 1 is L1. Okay, well, let's just simplify that just a little bit. It is L1. Well, what does that mean? It's the square root of x minus 1 squared plus 4 over x minus 1. That equals L1. So I can write that in there. That's the square root of x minus 1 squared plus 4 over x minus 1. Hey, we're slowly getting there, okay? So let's think about the area of triangle 1. Then we'll call this the area of the rectangle. This is the area of triangle 2. So my total area, if I don't run out of cord here, my total area equals the area of triangle 1 plus the area of triangle 2 plus the area of the rectangle. If I can write that expression and then take the derivative of that, set it equal to 0, solve for x, that's critical value, we should be able to do this. All right. Okay, where were we? All right, let's think about each one. The area of triangle 1. Well, the area of the triangle is 1/2 the base times the height. So 1/2 this base, which is 1, times this height. I don't know what that height is. Now, the red herring of this problem is, and I ran down this path, well, if this is 2 and that is y, this is y minus 2. And I flipped around on that for a while. Finally, that's because I was trying to figure that side out. I thought, well, I'm just being stupid here. Just put it all in terms of x and move on, okay? Then when we take our derivative, we just have it relative to x, and that just makes it that much easier, okay? All right, I'm going to call this h, h1. That's going to be the height associated with that triangle. So the area of that triangle is 1/2 its base, which is 1, times h1. Okay? That's going to be plus 1/2 the base times its height. Well, this one's height is 2. So I have 1/2 x minus 1, which is the base, times the height, which is 2. Well, those 2 is going to cancel. Plus, remember I said I can do the area of the rectangle. Okay, it's just 2 times 1. It's 2 times 1. It's 2. All right, so now we're still back to this, trying to figure out h1. What is it? Well, we know a squared plus b squared equals c squared on that triangle. So h1 squared, or excuse me, the L1 squared minus this side squared equals that side squared. So h1 squared equals L1 squared, which is the square root of x minus 1 squared plus 4 over x minus 1, all of that squared, plus this side squared, which is 1 squared, which is just 1. So it's 1 squared, just 1. All right, if I take this numerator and square it, h1 squared equals, the radical sign just drops off of it. So I end up with x minus 1 squared plus 4 over x minus 1 squared. You know the rule, a over b squared equals a squared over b squared. Okay, what we just did. Well, I want to get a common denominator for that. So I'm going to multiply that by x minus 1 squared over x minus 1 squared. So it's going to give me x minus 1 squared over x minus 1 squared. Well, what does all that mean? I'm not going to use the space to write them both over the same denominator. Well, I should. X minus 1 squared. So that equals x minus 1 squared plus 4. Oh, this should have been minus. This should have been minus, excuse me. Because it's this squared minus this squared equals that. So I've got h squared, h1 squared plus the base, we'll call that the base squared, equals L1 squared. So L1 squared minus the base squared equals h1 squared. My bad. All right, so minus x minus 1 squared. Okay, you guys, hopefully you guys were going, oh, you missed it. Okay, because this should cancel with that. And so h1 squared equals 4 over x minus 1 squared. Okay, so what does h mean? That's the square root of 4, which is 2. Square root of x minus 1 squared is x minus 1. Okay, all right, so we have h now. So we can go back to our area. We're getting kind of cluttered here. So area of triangle 1 equals 1/2 the base, which was 1, times h, which is 2 over x minus 1. So these 2's cancel. So the area of triangle 1 equals 1 over x minus 1. Okay, so now my area total was the area of triangle 1 plus area of triangle 2 plus area of the rectangle. So that equals, area total equals 1 over x minus 1 plus x minus 1 plus 2. So my area total equals 1 over, we'll just bring that up, x minus 1 to the negative 1 plus, I've got x minus 1 plus 2, which is just x plus 1. Now then, we have an equation for the area. What to do now? Let's take the derivative of that area with respect to x. So, negative 1 times x minus 1 to the negative 2, okay, times derivative of the inside, which is just 1, plus 1, and then derivative of that, derivative of x is 1, derivative of the constant is 0. So now I have 1 over x minus 1 squared plus 1, and we're going to set that equal to 0. Well, since I have a negative, I'm going to add that to both sides. Let me get up here. So I would end up, if I add this to both sides, it moves over to the left. So I have a positive 1 over x minus 1 squared equals 1. So now I'm going to multiply that, divide by the other, so I have 1 over 1 equals x minus 1 squared. So I divided 1 here and multiplied by x minus 1 over 1. Okay, so now I'll just take square root of both sides. Square root of 1 over 1 is 1, so that equals x minus 1. Add 1 to both sides. 2 equals x. Now let's just see what we have now. All right, h was 2 over x minus 1. So our height of that triangle 1 was 2 over x minus 1. So let's replace that height with 2 over x minus 1. Well, x was 2. So 2 minus 1 is 1. So what does that make this height here? It makes it 2. So well, we already had 2. And obviously this is not to scale. It's not scales off because this is 4 now. So 2 plus 2 is 4. So this point should be 0, 4. All right. What about the other point? So we have, well, x equals 2. So that point is 2. Because that point is x. So I have 2, 0. What about the area? Well, my area, let's go back to here, was 1 over x minus 1. So I have 1 over 2 minus 1, which is 1, plus x, which was 2. X is plus 2. Oh, so excuse me, that's plus 2 minus 1. So 2 minus 1 is 1. So that's 1. And then plus 2, because I knew I needed to end up with 4. I thought something went wrong. Okay, so the area is 4. Now, if you work through this and you change those coordinates and you recalculate the length of the line, you'll always get an area that's larger than 4. It's a good problem. Sorry for the messy board. I was trying to get it all on the board in one take, so without erasing. Okay, why are we doing this? We're crazy. We like to work math. I just think it's cool. Okay, but why are we doing it? We want to increase your skills so that you can do better on the job, get better jobs, have better opportunities. And how are we going to do that? Do that through math. That's how we're going to change the world and make it a better place, through math, okay? Study, study, study. Keep practicing. And we'll try to round up some more cool problems like this one. This was awesome. I enjoyed it. Hopefully you did too. Okay, like, subscribe, and share. You know the drill. All right, guys, that's all for now. We'll talk to you next time. Thanks.